I foreshadowed with the Kinect Wave there. Most of you know Kinect is a great part of the Xbox gaming system, a really cool way of playing games without needing a controller or handheld device. I get to play my movies. My daughters love it. Well, better, gaming is nothing to sneeze at, but the impact of Kinect has extended far beyond the world of just like Dance Central. Today, researchers are using Kinect's amazing abilities in a host of applications, from surgery to virtual fitting rooms. My next guest has developed yet another great application of Kinect, the ability to bridge the deaf and the hearing worlds through sign language recognition. Please welcome Professor Xilin Chen of the Chinese Academy of Sciences Institute of Computing Technology, Tim Pan of Microsoft Research Asia, and Stewart Tansley of Microsoft Research Connections. Stewart, we're going to start with you. Can you set the stage for us? Explain Asia Sign Language Project. What is it?
Sure. Good to see you again,
Yeah.
Chris. Another fantastic Kinect project. With researchers in China today, both in the Microsoft Research Asia lab and also at the Chinese Academy of Sciences. What the sign language translator does is, as you might expect, is it translates sign language. It provides a way for the deaf to communicate with the hearing without the hearing necessarily knowing how to use sign language. It's bidirectional, so the hearing and the deaf can now talk to each other. It also connects with the with actually the Bing translator too, so I can convert between, say, Chinese Sign Language and American Sign Language.
Wow. Wow. Seeing is believing, and we have a video here we want to show you, the Asian Sign Language Project. And maybe, Stewart, you can sort of explain what it is we're seeing as we see this video. Folks at home and around the globe want to know what this looks like. Okay. What are we seeing here?
Now, this is a research project, so we're going to show this very quickly just to give you a taste. The first is translation mode, showing how the system can recognize a deaf person producing a sign for a single word in Chinese Sign Language. There's the word that's recognized. Now we show a sign being shown in American Sign Language. The same system is working to also translate that word from American Sign Language. We can also do continuous sentence recognition. It wouldn't be very good if we just had to do single words. So here we're showing the system can recognize a sequence of gestures, in this case in Chinese Sign Language. You'll see the word list build up on the right-hand side of the screen because there's a statistical learning engine that's behind the system. It's that engine that is the core of the project. That's the core of the research that we're showing today. We also show, though, a communication mode that is showing the principle of how a deaf person could communicate with a hearing person, and the hearing person may not know how to do sign language. On the right-hand side is the hearing person is represented by an avatar. The avatar is going to sign on behalf of the hearing person and allow the deaf person to understand the signs that are being produced by the hearing person on their behalf. Equally, the system can translate the signs that the deaf person's making and read the phrases that the system is interpreting the deaf person that is signing. So here we have bidirectional translation between sign language in different languages and sign language from the hearing and to the non-hearing.
Wow. This is really fascinating stuff. Even to see it in action is really inspiring. And now I understand that the research for this prototype was done entirely in China. Collaborative effort here, I'm saying, amongst various Chinese academic institutions, Microsoft Research Asia. Professor Chen, can you tell us a little bit about your role, the Institute of Computing Technology, in this project?
Okay, so yeah, in our institute, our team focuses on sign language recognition itself. Yeah, you know, in this system, including sign language recognition, translation, and many other parts. We focuses on recognition itself. Yeah, you know, this is we're working on the real data. So the BUU, Beijing Union University, they have a special college for the education for this hard hearing person. So they have the person to collect the real world data and also help us to training and testing. So that's our role in the project. And I'm the PI of this project.
So what were some of the biggest challenges that you faced so far?
Yeah, the biggest challenge, I think, you know, it's the sign language also a kind of natural language. And compare with the spoken language such as English, we have alpha, beta, we have word, we have phrases, and we have sentence. But what is the basic components? What's the alpha, beta in sign language? So after many years research, we think that it just could be said, that's a PPT. What means the PPT? That means posture, position, and also the trajectory. That's the key issue and the key components for sign language. So the key issue and the key challenge is how to handle these components and to understand in a hierarchical way. Yeah, that means from the basic gesture to sentence. That's the really challenge.
Obviously, a lot of challenges,
Yes.
and I want to turn to Tim. Talk about the role of Microsoft Research Asia in the research.
Yes, actually, we are very grateful that we have partners like Professor Chen from the Chinese Academy of Sciences and Professor Li from the BUU. The role for the Microsoft Research itself is that we have two aspects. One is the technical contribution, which we offer technologies like machine translation and also pattern recognition, and we help to improve the system. And also we do some 3D rendering, for example, like the avatar you saw. And another aspect of the contribution is the coordination. Especially I want to mention that in our team in Beijing, Dr. Guo Bin actually worked with Stewart to coordinate the whole collaboration. If I can pick one keyword for this project, I will say that's the collaboration. It won't be possible without the external and the internal collaboration to work together.
Now, Professor, I want to ask you, what were some of the biggest challenges you faced?
I would say that Microsoft Research has a lot of cool technologies. And it's usually a challenge, or I should say opportunities, how to use those technology into real projects. And I think that that's the challenge, how to use those technologies. And I think that if I can say there is a resolution, I would suggest that we can think of collaboration. In this case, we work with the Chinese Academy of Sciences, so they help us to put together lots of isolated technologies into one, a lot meaningful project and make big impact to the society.
Now, I'm curious, a lot of your work is behind the scenes, figuring this thing out, getting it working. Do any of you have family members who are deaf or friends? Have you seen anybody actually use it, and what was the reaction?
Well, I have a sister. He's a teacher of the School for Hearing Impaired. She has been teaching there for 30 years. I told her about this project. She was so excited and pretty much moved. She said that every year she asked the students to write an essay on what they wish, what's their wish. We wrote articles about that before. We wish to be a president, to be scientists, whatever. And those students tend to say, we wish that we can speak. We wish that we can hear, that very fundamental capability we all have. So I'm really excited by this project because at Microsoft, we say that we help people to realize their full potential. Okay? And I think this project is really helping the hearing impaired people for their full potential.
Now, we've seen this prototype work we just saw in the video there in American Sign Language, Chinese Sign Language. Obviously, it has the ability to go beyond just Mandarin. What's left, technically speaking, to make the leap here, to make it work with, say, Spanish and beyond?
I think probably you used a very similar model, but I would say that it needs more database to train the system. That means we need a broader collaboration with universities and researchers from different countries.
I know that's a rather open-ended question is, hey, when you can finish, when can you accomplish everything? I know, but obviously that connects to the next question, which is, and Tim, when do you suppose we might see a base product kind of a thing that people can see and use?
I think this is starts with, this is a research project, and we have finished this prototype, and you can see this demo in this faculty summit. And we published 2 papers on this project, and I think that's a pretty good achievement in terms of a research project. And in the near future, we are going to implement this system in BUU, the Special Education School. And in the clinic, because lots of the students, they need to do sign language, but the doctors may not understand it. So we'll put that in practical use in the BUU. Of course, in the future, if this can become a product, I think we'll be very proud of it, and we are definitely willing to help. But I think for Microsoft, it's really up to the product group.
And I mean, assuming a product group was interested, and I can't imagine somebody wouldn't be, yeah, technically, what leaps do you have to make this a commercially successful item in the living room?
Well, I think that from Microsoft research who have been involved into technology transfer would understand that there's still a gap from a lab prototype to a real product. Okay, so I can see there's still a lot of engineering work has to be done. And I think another thing is whether or not this is feasible to the market. I think there are lots of feasibility study, marketing survey, things you have to do that I'm not really an expert to comment on that. But we'll be happy to see that happen.
Yeah. We're getting a lot of people weighing in online here, people posing questions for you guys. Stewart, they want to know if you could talk about some other NUI applications of Kinect.
So NUI, or Natural User Interface, has been a dramatic expansion of the way that humans can interact with computers, making the computer interface a lot more invisible to the interaction so that we can interact with computers in a more natural way. Speech, for example, gesture, things that we just normally do that we're born with. What we've seen around the world is an explosion of these technologies thanks to new sensor technology like the Kinect. But more importantly, perhaps, than the sensor is even the machine learning and the statistical learning that goes on behind the scenes of technologies like that to recognize gestures, to recognize speech. There's just too many to count on diverse projects. This is one example of a great collaboration that we have in Asia. But there's just an enormous number of these around the world in different areas, different applications of natural user interface.
It seems like when it comes to exciting technology, it's no different than like a child on their birthday opening a present. That's great. What else? We're getting a lot of what else questions on here. This one for Tim says, can you tell us some of the other collaborations that are taking place between Microsoft Research Asia and Chinese universities?
Oh, actually, there are a lot of them. Every year we collaborate with the university in Asia for tens of projects. And for example, this year we collaborate with the Chinese Academy of Sciences and several universities like Beijing University working on e-science, how to use Azure to accelerate the e-science research in atmospheric sciences and many other areas. And also the coming year we are going to do urban informatics, how to solve urban problems when we use, for example, cloud computing technologies to do that. So there are lots to come as well.
Now, again, trying to make leaps here in all the technology. Many have seen the demo, the video of another Microsoft research project, the speech-to-speech prototype. Translates person's speech and then speaks the translation. In that demo, the speaker is talking in English. The system translates, speaks the words in pretty natural-sounding Mandarin. So if you had your sign language system you set up for Mandarin Chinese and for American English, could you link the two together? And of course, people are saying, in other words, would it allow a Chinese signer who knows no English to communicate with an American speaker who knows no Mandarin?
Yeah, I think it's definitely doable. And as I always say, that this project is really a project of hope.
Yeah.
You can imagine that, for example, a hearing impaired Chinese student who wish to speak with other Chinese people. Okay, but if someday you tell them you are not only communicating with the Chinese, you can communicate freely with Americans as well. I would say that's a big wow. This is what's the first thing I want to share. And the second thing I would say that every fan of science fiction has a dream, which is the universal translator. Okay, and what we say about the universal translator is usually speech to speech. I would say because of this project, we wish that we can add something more, which is not only speech to speech, but sign language to speech, speech to sign language, and the sign language to sign language. I think unless we include the hearing impaired people, there's not universal. Okay, only universal if we include everyone.
Right, absolutely. Professor, what do you think for you? What's the best case scenario? Where do you hope all of this will go?
Yeah, I think in the next step, we have different model, and for different languages, we will try to universalize one, and using the new data so that we can train for different languages, different sign languages. And the next step, so the sign language should be, I think, a kind of language, and to bridge the hearing person to the hearing person. Mm-hmm. That's our dream, and we have worked for this for more than 10 years. From basically, at the beginning, we're using the dead groove. It's very expensive and easy damage. That's in 10 years ago, and at that time, another professor who is working in Peking University right now, Professor Wen Gao lead our team working on that system. And so that demo system works quite well, but it's expensive. So that's why we seek more off-the-shelf devices for this sign language. And I think, at this time, Kinect is one of the best devices for this purpose. That's why we're using the Kinect for sign language recognition. And we know, for the sign language recognition, it's also a kind of interaction. And Kinect is in the distance, the interaction distance. So it's a right devices, right technology. I think it's a good combination in the future.
Gentlemen, thank you. It's absolutely fascinating info, or as I should say, thank you. Thank you in American Sign Language. It's pretty inspiring to see the way technology can be applied in such an unanticipated but really meaningful way. Thanks to Professor Chen, Tim, and Stewart. Thank you all for being here. We